Let's start part 5 of the exam preparation paper, and this also has a difficulty level of 2, so just keep that in mind. Now question 34, is asking us to solve this equation. Now I really don't like working with fractions. Fractions is always bothering, so what I like to do is try to eliminate all the fractions out. Now to do that, I like to eliminate the denominators, so have a look at the denominators I have. I have 2 and 8. To eliminate those, I simply multiply out everything by the highest common factor of, the multiple of 2 and 8. Not highest common factor, highest common multiple, so I can eliminate out the denominators when I multiply by it. So what is the highest common multiple of 2 and 8? Should be 8. So I'm going to multiply every single term by 8. So I multiply 5x on 2 by 8, this one by 8, and this whole side by 8 as well. And in that case, see how 8 divide by 2? See how 8 and 2, we can divide it? So that one will become 4. 8 divided by 2 is 4, so 4 times 5 becomes 20. And then here, the 8s will just completely eliminate, completely cancel out. So I have negative x minus 2. Just keep in mind there's a bracket, invisible bracket there. So if I cancel out those 8s, I do negative x and negative 2. So negative becomes positive, so positive 2 here, so don't make that mistake. Now here, just expand out the brackets, 8x minus 8. That was just a very simple one. Now all we need to do, we've got rid of all the fractions, just gather your like terms and simplify. So I've got this. See how here 20x minus x is 19x, and I'm going to move this 8x onto the other side, so I have negative 8x on this side, so 19x minus 8x will become 11x, And then now of course the 2 I will move over to the other side as well, so I have negative 8 minus 2, which becomes negative 10. Just some easy simplification. And then to get x, we just simply divide both sides by 11. So x is negative 10 on 11, and that's the solution. So after you eliminate out the fraction, keep it with no denominators, everything becomes very, very simple. So that was question 34. Question 35. We've got some absolute bars again. Some of you won't like absolute bars. I know a lot of students don't like using absolute bars, but I'll show you it's very, very simple. If the absolute value of x plus 2 equals to this, the inside here, the x plus 2, can be positive or negative, because the outcome, no matter what the inside is, will become positive. So the inside here, x plus 2, could be positive 2x minus 1, or negative 2x minus 1. So this is positive 2x minus 1, so it's just 2x minus 1 as it is. But this one here, it comes from negative 2x minus 1, which is, if I expand out the brackets, I'll have negative 2x plus 1, because negative makes a positive. So that's how I get two equations out of that single equation there. Because of the absolute bars, and you can see now I've eliminated out the absolute bars. So all I need to do now is solve them individually. So starting from over there, just gather your like terms. If I move 2x onto this side, I'll have x minus 2x, which is negative x, and move your 2 over to this side, so I have negative 1 minus 2, which is negative 3. So x is just positive 3. So that's how I get that. Now with absolute value questions, it's very important for you to check your answers, especially if you have pronumerals on both sides of your equation. So make sure when you get your values, you don't stop there, you must check your values. And that's also part of your marking. So if you don't check, you will get marked down. So just keep that in mind. So I'm going to check it. So I put 3 into here. So it's going to be absolute value of 3 plus 2, and I put 3 into there as well, so it's 2 times 3 minus 1. Now 3 plus 2 is 5, it's just a positive number, so there's not much point of having the absolute the bars there, it's just 5. And 2 times 3 is 6 minus 1 is also 5. This is obviously true, very, very true, therefore x equals to 3 is a solution. So we just confirmed that. Now here, we're going to solve this individually as well. So do the same thing, just gather your like terms. I'm going to move negative 2x over to this side, so I have x plus 2x, 3x. and 2 over to this side, so I have 1 minus 2, which is negative 1. And to get x, just divide by 3, I have negative 1 over 3. Okay, and again, don't stop there, you must check. So I'll put that back into my original equation. So I have negative 1 on 3 plus 2 inside my absolute bars, and put the negative 3 in there as well. Now if you check this, guys, you'll get this part, this inside is 5 on 3, and with the absolute bars, it definitely should be positive, right? But this one here, if you calculate this, you get negative 5 on 3. Now negative 5 on 3 is not positive, so therefore these two sides of the equations do not balance. They're not equal to each other. So obviously this is false, it's not true. Therefore we cannot say this is a solution. Only x equals to 3 is our final solution. So I've got that away, okay? Ignore that one. Okay, so we only have one solution for this one, okay? But make sure you show both sides of your working out to get full marks. Alright, so that was question 35. 36. Sketch absolute value of x equals to 3. Okay, now again, absolute bars mean no matter what you put inside, you get answer as positive. So in this case, I want you to solve the equation for x. You'll see that x is plus or minus 3. Because even if x is negative 3, the outcome, no matter what that is, will become positive 3. So therefore the graph indicates two vertical lines, one which is negative 3 and the other one which is positive 3. Both of these lines are part of this one graph. Okay, so just make sure this is negative 3 and this is positive 3. Okay, so two vertical lines, that's the graph that you're after. So that's the answer to question 36. Okay, that was question 36. 37. Now y equals to absolute value of x. Now this question, okay, what I want you to do is sketch y equals to just x first of all. Don't worry about the absolute bars. Try to ignore that for a second. Just sketch y equals to x. This is your very simple, most basic linear graph, isn't it? That's y equals to x, right? Just a line going across the origin. Now, we have to sketch y equals to absolute value of x, and to do that, we must convert all negative y values to the positive side, because absolute value means it's all positive. But see how this part of the graph here is the negative part, which is below the x-axis, which indicates y is less than 0, but we don't want anything less than 0 because we want everything to become positive. So all we need to do is this part of the graph, we reflect it up to the positive side, just like that. So this part we reflect it up to the positive part, so this x-axis acts as a mirror, okay? And therefore this part, this V-shaped graph here, is your final solution. Okay, so is that pretty clear? So for any particular graph or any absolute value graph, what I want you to do is ignore the absolute for a moment, and then anything that turns out negative, you just reflect it up. That's the key thing to drawing absolute value graphs. If you think of it that way, it's very, very simple, no matter what type of graph you get. Okay, so that was question 37. Question 38, all right, we're going to simplify that expression, and with these fractions we must make the common denominator, right? And in order to do that, I'm going to first do some factorization. So I factorize this one by x, which is the common factor, so I have x minus 2 left inside the brackets, and here 2 is a common factor, so I took 2 out and x minus 2 is left inside. Now I can see that x minus 2 is common, but here we have an x, but we don't have the 2. And here we have a 2, but we don't have the x. In order to make this common denominator, we must have all factors inside both terms, both denominators. So what I'm going to do is multiply this fraction by 2, but make sure you do it to both top and bottom. And this one I'll multiply by x because we don't have the x, so make sure you do it to both top and bottom. So this is what I get. So this side I'm multiplying by 2, so I have 2 on top, and then I stick the 2 on the bottom as well. And this side I'm multiplying by x on both top and bottom, so 1 times x is x, and I stick an x inside that as well. And now we have a common denominator. Okay, so we've got the same denominator. All we need to do is simplify the numerators. We're adding, so the answer is just 2 plus x over that common denominator. And that's your final solution, so have a look at that. Okay, so that hopefully this is not too bad, just making the common denominator and simplifying into a single fraction. And that's it, we can't simplify any further. So that's your solution. Now question 39 says solve this equation, okay? Now, alright, we've got some fractions again. So again, I don't want to have any fractions, so we're trying to eliminate out the denominators by the highest common factor of 4 and 3. 4 and 3, okay? So what is it, guys? Should be 12, so I'm going to multiply out everything by 12. So multiply this fraction by 12, this fraction by 12, and the 1 by 12 as well. Okay, and here you can see that 12 divided by 4 is 3, so I have 3 times x plus 1. And 12 divided by 3 is 4, so 4 times 2x, that's what I put there, and of course 12 times 1 is just 12. Okay, yep, very simple. Now all I need to do is expand and simplify. So from now on it's just very basic algebra. So expand it out, this is going to be 3x plus 3. And 4 times 2 is 8, so 8x, and then minus the 12. Gather your like terms. So if I move 8x over to this side, I'll have 3x minus 8x, which is negative 5x. Move your 3 over, negative 12 minus 3 is negative 15. Divide both sides by negative 5, so x will just be 3. That's your answer, guys. So that was very, very simple again. Again, the most key thing is to find that common factor of the denominators and multiply out everything by it. Okay, so that was question 39. Question 40. Alright, this time we have fractions again and we want to solve for this equation. But whenever you see a fraction equal to a fraction, the key method I like to use is the cross multiplication method. So if you see a fraction equals to a fraction, multiply out crossways. So we multiply the x with the x plus 4 and we multiply the x plus 2 with the 3. Like this. So x times x plus 4 equals to 3 times x plus 2. Okay, now if you don't really understand why I did it like that, well basically the common factor of x plus 2 and x plus 4 is x plus 2 times x plus 4. So if I multiply both sides by x plus 2 times x plus 4, this side the x plus 4's will cancel out. This side, x plus 2's will cancel out. So eventually we have x times x plus 4 on this side and 3 times x plus 2 on this side, if you see what I mean. Okay, if that's confusing for you, try to use some paper and write that out by multiplying this whole expression onto both sides, because that's the highest common factor in this case. Okay, but I won't go through all the working out, but that's basically what you do if you don't really understand why I'm doing the cross multiplication. Okay, eventually you get the same answer. So that's what I have there, and all I need to do now is expand and simplify again. So this side x squared plus 4x, this side 3x plus 6, just some simple expansion. Move everything onto this side, and because I see an x squared, it looks like it's going to be a quadratic equation. So if I move 3x onto this side, 4x minus 3x is just x, and then the 6 will become negative x. That's all going to be equal to 0. Okay, just some simple simplification. And then let's factorize this. It's a quadratic, so look at the factors of 6, 6 and 1, 3 and 2. What do you think we're going to be using? We need to make positive x. Okay, positive 1x. So I think I'm going to be using 3 and 2 because I know that negative 2 plus 3 will make positive 1. Okay, so that's why I have x minus 2 and x plus 3. Just some factorization that we've done a lot before, right? So make sure you know your factorization before you do this. So therefore, what is x? X will just be negative 3 or positive 2. That's the two solutions that I have. Okay, so just remember that cross multiplication method. Question 41. Alright, we're going to simplify this expression again. Now it's a minus, subtracting, so again we have to make the common denominator to make it into a single fraction. So first thing I would do is factorize it. So this one, the common factor is y, So I factorize by that and I have x minus y left inside the brackets. Here the x is the common factor, so I have x minus y left inside the brackets. Okay, just taking out the common factor. Now have a look at, compare these two denominators, guys. I have x minus y here and x minus y here as well, so that's common, which is good. And this side I have x, but I don't have the y. And this side I have y, but I don't have the x. So in order to make them equal to each other, I should multiply this fraction by the x. So multiply it to both top and bottom. Don't forget to do it to both the numerator and denominator. And this side I should multiply by the y because it doesn't have y. So make sure you multiply y on top and bottom as well. So if I do that, if I multiply this side by x on top and bottom, I should have x squared on here. And then I have the x, y on the denominator. Okay? And then if I multiply top and bottom by y on this side, I'll have y squared here. And the denominator, I add an extra y. Okay, so I have x, y here as well. And now you can see that we have the common denominator, and now we can make it into a single fraction. So you keep the denominator the same, x minus y, and you subtract the numerators. So I have x squared minus y squared. Now that's not it, guys. I hope all of you can catch that these two are difference of two squares. So we can factorize further. So let's factorize the numerator like this. It's going to be x plus y, x minus y. Okay, just the difference of two squares that we've done a lot before. And now, I think we can cancel out some values. See how that is common? We can cancel those two out. So the final solution is just x plus y on xy, and that's it. Alright, so how simple does that look? Alright, so again the key thing is to make the common denominator, and always make sure you can factorize fully until you cannot factorize anymore. Okay, so that's the answer to question 41, and that concludes part 5.